Yes, I have done it.
So this is a basically this is a line detector system which is using the Arduino board. So firstly, introduction to Arduino. The Arduino is an electronic gadget which helps to connect with the and control the things, objects.
What's a microprocessor?
So microprocessor, there is a inside there is a small chip, black color.
What's a sorry. Okay, what's a do you know what's a microprocessor?
So Mega 2560 model.
What's a sensor?
Sensor is IR sensors, infrared sensors. I'll explain each and every component in very detail. So that the Arduino board is it will help us to control the systems. We can bring our ideas into action. So it was created in a design institution. It was designed there to help the students who have no prior experience about the electronics or programming, so that they can learn and make better use of it. Students will use it for education purposes and engineers will use it for prototyping purposes. That's how it works. And for example, it is just like a human brain. Like how we make decisions by seeing and hearing in our environment, it will also make decisions by taking the inputs from sensors. Firstly, it will take input from sensors, processes that information, and then sends it to the DC motor to control its environment or to control the objects that are connected to it. So that's how the Arduino board works. So this is the picture of an Arduino board. Here, it is first of all the Arduino board is a powerful microcontroller which helps us to move the objects or do those actions through Arduino. So this is a microcontroller. This is like the brain of Arduino. In the microcontroller, it is able to make decisions. It will take decisions like whether it should go to left or right or something like that. And it will also take the input from the sensors and give the outputs to the other objects that are connected to it. So this is the brain of it. And then these are the pins which enable the Arduino board to communicate with the outside world. For example, if we mount any of the things on it, it will help it to communicate with the outside world. And the infinity symbol, always the Arduino is represented with an infinity symbol. So the infinity refers to it has infinite possibilities. Like it's not limited to just one type of project. Like it's not like only line detector can be made. So many other things can be made from Arduino, like waste segregation. It can detect wet, dry, something like that. And so this is the overview of the Arduino board. This is the USB cable where in order to program the Arduino board, we should write the code in Arduino IDE first, and then we use this kind of a USB cable to connect with the CPU and this Arduino board, and then we program it to run in a certain way, to do some certain things. So yeah, communication happens with the USB model. So the next is
Just one quick thing. I know a bit about this. I just how you created a code to run on laptop.
Sir, firstly, while loop is used here. Okay, sir. Because the while loop, when we use while loop, it runs continuously until and unless the condition is false. So how this board is programmed is, it is using C++ language and the loop has been written. It will run until the power is off. That means the condition becomes false in software terms. But here, until we off this battery, till then it will be running with the while loop. And how I've coded the sensors is, so for example, this is a black line and the sensor has to detect it. The black line observes that infrared light rays, and then for the code, the left turn and right turn we should do, right? So while doing the right turn, it should behave in a certain way. It can just not go forward. It should behave in a certain way. These wheels will go straight. These wheels will go backward. Then only the right turn and left turn can be done. So that is how the left.
So is it just only the Arduino programming you are done, or you are using some your own logic or your own implementation?
Sir, I've used like Arduino board and I've taken guidelines from other sources. I've taken so many resources. But the trickiest part was coding the left turn and right turn, because the while loop was disturbing so much. We had to, the low and high, those things will be there. No? When we did the testing and all, it took so many trial and errors, because once we implemented, it was turning in the same direction like this, and once we implemented, it was going full straight, so not detecting anything. Like that, we did so many trial and error, setting the high, low, and delay. Delay will be there. How many seconds we should keep the delay? Like 500 seconds, milliseconds, or like 100 milliseconds. Based on that, the latency rate, everything we decide in the code. How in what time it is turning left, how much time it is taking to turn left. Everything is coded in Arduino IDE, and then we upload it to the board. It understands it and implements it accordingly.
So why this idea? Why?
Sir, actually, what I thought is till our final years, we have done only software projects. Only software projects. So firstly, it is very damn easy to write a code, a while code, and say that this is how it works, so it happens like this. But when we...
Did you do this only for this?
Yeah, sir, I did it in 3 days.
You did 3 days?
So,
only for this one?
so not like only for the sake of competition.
No, I'm just asking, was there any other competitions where you wanted to participate?
No, sir.
And
It was did from the scratch, sir. I only visited the shops, I bought the equipment, like these small...
So from where did you get this idea?
Sir, my uncle is a software engineer. He speaks a lot about Arduino, like you can do these things, that things. So I always had that in mind. At least once I should try this kind of a thing. So
The reason why I asked is that normally people focus on software.
software.
No,
Yeah, sir.
so when you did it,
So-
just curious.
Yes, I can explain even the logic and implementation, because I did everything from the scratch. Even I had to visit so many shops to bring these small nuts, because they are not available everywhere. And yeah, and yeah. So yeah, how my project works is, first of all, so firstly, these sensors will detect the line, whatever is there through infrared rays, and then it will send the information to Arduino board. Second step is it will send the information to Arduino board. After it sends to Arduino, it will all the information that is taken by Arduino, it will send to this DC motor, and then it will try to implement that thing in overall project. So Arduino board is like the brain of my project, sir. So and then yeah, accordingly the robot follows that line, and that's how it works. So hardware components, the robot and built-in blocks. Firstly, I explained about this Arduino, and these are the sensors. So they are very delicate. Yeah, these are the same ones. So this is the light, sir. The infrared light where it goes, and then observes. So the logic and implementation of this sensor is the blue line. It will detect. It will observe that light and then detect it. Yeah, black line. So after that, the white surface is there. No, it will reflect the light. it has to ignore that. So it works that way. And these are the adjusters. For example, this is the to adjust it in a certain length.
The proximity of
Proximity.
how much you
Like how in the projector, sir, when we want some clarity, we'll do some changes, no? Like that, we had to do this to adjust the length of it, and then so that it can detect it properly. And the reason why they have kept in a certain length is because the tape size is this much, and it has to detect with these sensors, and it has to move accordingly to that. So that's how this sensor's whole logic and implementation works. And then this is the Keyestudio Keyestudio L298 motor sheet. What this basically does is, so these motors, motor A and motor B are there. No? There are 4 motors in my project. There are 4 motors, and for each motor there is a black wire and a red wire. And from left side we take 2 red wires, and then we will take off the jack of it and then twist it and bend, and we'll insert it into the motor A. Like that we'll do with the black also, because there are 2 holes for motor A. And then for that we will remove these screws, which is very tiny and all, and fit it in a proper way. Then only it will work. And the same with the left side also. We should twist them and insert into these things, so that after testing only we will know whether they are connected properly or not. And these are the pins that are these are the pins that are connected to Arduino. So for example, this is an Arduino board, and this is a motor which holds. Yes. So it's DC motor which will, for example, the Arduino alone cannot.
what kind of board is
The Keyestudio is.
what is the
Sir, why
use
we?
of it? Why do we use it?
I say, sir. So, for example, the Arduino board, it alone cannot handle all the objects that is in there. It cannot power supply that much current to all the objects and make it move. So, for the support of Arduino, and it has the power to power supply to all the objects that it has been connected to it. So, in that way, the DC motor helps. So, this is all about this. I explained about these motors. It has 2 wires, and this is a chassis. Chassis means these things. These things are the chassis, which helps for the movement of the object. So sensor logic and intelligent. I explained also how those lines it detects and turns left and right. And so awaited.
You want to do it?
Yeah, I've made.
Yeah.
So we have.
I'm not wrong. Like there's something called P, potential difference algorithm, which you need to put it over.
Yeah, sir, it was a program that they, I stayed awake all night and did so many times. It was a hectic. So I thought this was. I did testing in the morning also. I gave it complex patterns. At that time it was able to do, but maybe now it has some battery.
No, that's fine. That's okay. I understood this. To tell you, I have done this. You know, IIT Bombay. They host. They have a test. We go in January. They have a competition. IIT Bombay is engineering. Different as a physics. So I have done the same thing. So I could relate it. I know IIT Bombay, it's in CCR and logistics. So you need to, if I'm not wrong, I'm not sure. So that's called potential difference which you need to work on. For example, you need to develop your own logic in order to make it work. I mean, this is a simple, right? So there they have a specific design, predefined design. So where you need to make your or to work. So that is a specific one. I would suggest try for it. If you have
That logic I need to try and implement.
it is a bit difficult to find it on the internet. Last question. What's the use cases for this?
Use cases, in hospitals, healthcare and safety they are used. For example, there are some certain areas which are sensitive. That if we go, for example, if you take COVID, we are not supposed to enter into the room of a person who has infected with COVID. So at that time, what we can do is this lie detector system helps a lot in that case. It will take the proper medicines, the food trays and the report cards, everything to deliver to that, because it follows a specified pathway, right? So by following that pathway, it will help those patients, and also it will minimize the workload of the hospital staff.
One last question. She has done this simulator. She has done it using AI. Yours is also the same, but yours is a physical one, right? I'm just trying to give you a problem, and I'm expecting a solution. How do you solve it? She's using AI. You are using Arduino. How do you match this? How do you match this? How do you say AI is better than this?
Sir, AI is definitely, hardware is definitely better than AI, sir. AI is only confined with software, if you do it in a software thing. But when we do it in a hardware, we will understand the complexity. It is not so easy to write a code and implement it in the hardware. It takes a lot of time to do it from scratch. And also, when we do it in the hardware, that's where it comes to an implementation. That's where we can have some use of doing that. When it is in the software, it just says that. So it is important to do it in hardware.
Which is easy to manage. Just how
Obviously,
she always says this.
easy to manage. In terms of what, sir?
Whatever you do. In terms of anything, like if something you ask for is not moving. Like it can take a left and over. So it comes as a problem for you. Right? That's a problem. You need to solve it. Right? Which one is better? Like easy to solve. Yes or that?
So in terms of what you said, sir, AI is better because it is easy to maintain and.
If you ask me, I say this.
Sir,
Yeah, I say yes. And I know that I will say. I want you to think with your answer. Not why it is right to do.
sir, because hardware, after implementing, we can easily manage it. It will be in control of us, no? But AI will be prone to.
Yes. So, are you right? Different from what?
So why I hate hardware is I had that in my mind from a long time. I must implement something in hardware. It is not so difficult. Also. In computer networks, we have learned that taking off the jack of the wire, twisting the wire only in a theoretical way. Never have implemented it in real life. But after doing all these small, the twisting, taking and all that, it takes lots of patience and effort. So I try that knowledge here and